Welcome class to the cryptography and network security courses. Another lecture of cryptography. Today we'll discuss about data encryption standard. So this data encryption standard, it is a particularly block cipher. We'll discuss what is block cipher and what are the different types of cipher. As you know already, cryptography is nothing but the technique of encryption and decryption. And encryption is the process to convert a plain text into ciphertext, and decryption is just the opposite, convert the ciphertext into plain text. Keeping this in mind, we need to understand how data is encrypted and what are the processes for the encryption based on a particular algorithm and particular process and a particular functions. Moving to the next. I am Asis. As you know, I am an instructor for cryptography and network security in this semester. So, the encryption is the process to get ciphertext from the plain text, and decryption just the opposite of it. Then we moving towards the type of cryptography. There are two type of cryptography. As you see, first one is symmetric and second one is asymmetric. In this class, in today's class, we discuss only about the symmetric cryptography. Okay, as the name suggests, symmetric. So it must be encrypted using the same key and decrypted using the same key. So let's have a look. The symmetric encryption scheme has a 5 component. Being a computer science student, being a cyber security specialized student, you must know, or you already know, that in a cryptography there must be a plain text, there must be a ciphertext. When there is a ciphertext, a conversion algorithm must be there that convert plain text to ciphertext. So we need an encryption algorithm. When there is an encryption algorithm is concerned, there must be a key to jumbled up the bits or alphabets or whatever input coming from the user for the encryption. So the 5 common ingredients of any cryptography technique is plain text, of course, the message that's to be sent, and an algorithm that convert it into ciphertext, and of course the reverse algorithm that decrypt it to get the plain text at the receiver end. Okay, so let's have a look to the model how this symmetric cryptography works. This is the standard model of cryptography, or we can say this is the symmetric model. In this model, what actually it wants to convey. So this is our plain text. This is our plain text message that we want to transmit. So we put it into the encryption model. We put it the algorithm with using this input. So the algorithm gives a key, this is the key, and add this message and lock it. This is the symbol of a lock, and lock it what we called as y is equal to encrypted k comma x. K is the key, here k is the key, and x is the message. Here x is the message, which in turn produces the cipher text, which in turn produces the cipher text at the receiver end. When the receiver wants to read the message, the receiver using the same key. This is same. This key and this key, these two are same. The same key as it is k, it is k, the same key again utilized and using the reverse algorithm. See, using the reverse algorithm, this is y equal to encrypted k comma x, and this is x is equal to decryption k comma y. So again the receiver get the plain text. Okay, so the way the message convert into encrypted form and the way the message convert into decrypted form, or convert from plain text to ciphertext and ciphertext to plain text, this describe the symmetric model. So now the question arises, how to uh, get the ciphertext from a plain text. So to get this type of implementation on data, today we discuss the data encryption standard, which is an algorithm who provide the standard of encryption upon data that converts a plain text into ciphertext. Moving to the next, let's have some brief history of this data encryption standard. This is in short called DES. It is a symmetric key block cipher. Symmetric encryption, as we know, in a symmetric encryption, the similar key or same key is used for encryption as well as decryption. If we take example, in substitution cipher, we have seen that in a scissor cipher, if we do +3 to substitute the alphabet, in the decryption process, if we do -3, we can get the plain text. So here 3 is the key and plus minus is the operation. In encryption, if you are doing plus, the reverse is minus in decryption. So data encryption standard is a symmetric key block cipher. Now what is block? Published by NIST, National Institute Standard and Technology. But DS was first published as FIPS, that is Federal Information Processing Standard, in 1977. Okay, so much ups and downs are there when DS was to be published, and after few time it was popular, so that it has been published. This is the standard process sequence of data encryption standard, that is known as DES. Here in this figure, if we see 64-bit plain text, now it's time to discuss what is block cipher. So block cipher is nothing but it takes input a block of bit. Let's understand this. This is 64. So I have a block of 64-bit. Let's have this is a block and this content, let's assume this content 64-bit of plain text 011010, that is the 64-bit of plain text. So this plain text input into the DES algorithm. Okay, that's why encrypt data in block size of 64-bit each. Every algorithm, every encryption algorithm has a capacity to convert a size of blocks. This is block cipher. Other algorithm, there are other algorithm also, they are known as stream cipher. We study will study what is stream cipher. Now we'll concentrate on block cipher. Block cipher means it's come in a block and all the 64-bit input into the algorithm at a time. Okay, 64-bit of plain text goes as the input to DS, which produces 64-bit ciphertext. Obviously, when 64-bit plain text input inside the algorithm, so it will give output to 64-bit ciphertext. Okay, the same algorithm and key are used for encryption, decryption with minor differences. Now, what is the differences we need to discuss? So, as we already know, whenever we are taking some input, we need to add some key. So here, the first part is initial permutation. Okay, permutation means this is the block of 64-bit. This 64-bit changes into 64-bit, the 64-bit as it is, but only changes is changing of their positions. This bit may be come to this. This bit may be come to this. Thus changing of position, that is known as initial permutation. After initial permutation, the round 1 started and this particular model is implemented, or this particular model is functioned by Fistel. One function is there inside this round. So when this first permutation done, when this particular block come inside in round 1, it added with 48-bit key. So 64-bit this side, 48-bit this side. Okay, we'll see the detail of this round. How we got this 48-bit? Actually 50-bit cipher key is adding, but the round key generator generate only 48-bit, keeping the parity 8-bit apart. Okay, then moving to the next, that's the first part, that is the how DS work. 64-bit comes inside DS cipher, encrypted ciphertext, 56-bit key both side. Then again, this is the normal overview of a DS block cipher. Okay, so moving to the permutation part, this is the permutation part. How the permutation occur or initial permutation held. See, we are inputting 64 bit of 64 bit of block into the algorithm. So from 1 to 64, this is bit. Permutation means the position will be changed. So this is this fast will be at 40. It may be something else. 58 will be at fast. 64 will be at 25. So this after this permutation, this is the sequence of bit. Okay, where fast bit is the 58th bit. Okay, this will be input to the round 1. Okay, after round 1 again round 2 will be there. After final 16 round, because DES has 16 round, after final 16 round, whatever the sequence of bit we are getting, again that is going to be permuted. So first will be again 58, one may be the 40, and this is the final 64 bit we are getting at the last. Okay, so we have done the initial permutation. Now we see what is there in round 1. So in DS there are 16 rounds. In DS there are 16 rounds, and each round of DS is a fiscal cipher. Now what is fiscal? Fiscal cipher is nothing but a function that is f of r1 minus 1 comma k1. So what is r1 minus 1 k1? See, we know that DES is a 64-bit block cipher who takes 64 bits. So this is 32 bit, this is 32 bit. Both adding both, we are getting 64 bit. So the left 32 bit and this is right 32 bit. This has been differentiated. The left bit first come to the fiscal function. Okay. The right bit keeps as it is. Then the 56-bit key comes into existence, and excluding the parity bit, the 48 key comes inside. Okay, then this function creates some block of bits, and the left bit again mixed XOR with the fiscal functions, then it go ahead. Then the left side bit go to the right one, and the right bit comes and it assigned to the left one. So this way rounds goes and goes and goes. So in each round there is a 48-bit key. This is 56-bit key comes, and 8-bit parity has been discarded here for safety purpose, and finally 48 has been implemented to the algorithm, and this is called mixture or XOR, where this key and R1 this will be creating another block of code, and this XOR comes to the swapper, and this swapper swap left to right and right to left. Again, this is the round 1. After this round, in the next round, again this comes into existence, and R1 again key from this side, this goes to f of function, then this create a block, this comes into existence, then again XOR, then this goes to this side and this goes to this side. Okay, so that is round 2. So in each round we are getting 64 bit of blocks, and that blocks again input for the next round. Hope you understand. And these are the figure from the books what we have studied, that is Forojan book. Next, what is this XOR? What is the XOR? So the 32 bit come inside an expansion P box. That means this 32 bit expanding and it's become 48 bit. How it is done in next slide we'll see. And the K1 key 48 bit comes, and then XOR will be happen and the 48 bit comes inside. Then S boxes, that means substitutions going on. Number of substitutions, 8 substitutions going on. 1 2 3 4 5 6 7 8. 8 substitutions will be there. After that, see, after that this is 48 bit, this 48 bit, then it's become 32 bits. So here the 32 bits will be expand to 48 bit. Again here the 48 bit will reduce to 32 bit. Then straight P boxes, permutation boxes. Then this 32 bit uh, goes out from the function, that F function or fiscal function. Now this is the expansion permutation from 32 bit. Okay, the first bit, then the 32 bit divided into 8 different bit, 4 4 4 4. So 4 and 4, this is 8 different block of 4 bits. So these 4 bits comes into this, then from 32 bit, one bit is here and these bits linked with the first bit of next block. So this way, this 4 and this 2, this is creating 6 8 blocks of different blocks. So this becomes 48 bit output. This become 48 bit output. This is the bit for this, and these 4 bit come from this 32 bit, this one, this one, this one, and this is same for this one, and this bit comes from this 32 bit, and this bit for this, and starting of this bit from the previous block. So in this way this form the 48 bit output. Okay, expansion permutation. Now this 48 bit, again this 48 bit, after uh, getting out from the function, it convert into 32 bit. How it is possible? The 48 bit data from the second operation divided into 8 bit chunks. See, this is 8 bit blocks individually. This is 8 bit blocks, and each chunk spread into a box. The result of each box is 4 bit chunks. How this is going to convert 4 bits? Because we just taking this one and this one as a reference bit. In the next slide we'll see, this is 6 bit, 1 2 3 4 5 6, 6 bits. So this first bit and the second bit, suppose this is 0, this is 1, so this is 0, this is 1, like this we can take, and the value we can take, and we just make a 4 bit of the corresponding bit group. So from the 48 bit we can get the 32 bit block from the S box. So like this we have 8 S boxes, 8 substitutions boxes. The position will be substitutes, 8 substitutions boxes, so that confusions and diffusions are there. Okay, what is confusion, what is diffusion, we'll discuss in class. Okay, next, moving to the next. Now we see this starting permutation has been done. After starting permutation, in the round 1, first key has been added to the right side. Then then within the fiscal function we XOR the right side and key with the left side, and we are getting some block of code for the round 2. So how this key can be managed? So the key generation. So the key is mainly 56 bit. So this is 64 bit key with parity bit 64 bit. So parity drop, then it is 56 bits. Now there is a shifting. That shifting depends on in 1 to 916 the shift will be 1 bit and other it is 2 bit. So this 56 bit I can divide it into 20 bit with left and 28 bit right. Okay, then 28 bit here, 28 bit here, and compression p box permutation boxes. So it's becomes 48 bit, that will go for the round 1. Then shift left, again shift left, and 48 bit compression key box, again it is going for round 2. Likewise it provides key for round 1 to round 6. Okay, if we see in a single slide, this should be the broad level steps in DES. So Fistel cipher model is a structure used to develop block ciphers such as DES. In maximum block ciphers, Fistel cipher has been used. So 64-bit plain text has been comes into the algorithm. Initial permutation is there, then it is divided left pan, right pan. Then in each round, key has been added to the right side and left side. And XOR is the function. Then they swap each other. Left side become right side become left side. Again, that particular thing is going on from 16 round. After 16 round, final permutation will be after 16 round, final permutation will be happen, and then we'll get the 64-bit cipher text, and this is called as DES, data encryption standard. Okay, same encryption as well as decryption algorithm is used. If you want to decrypt this thing, just follow the reverse process. The key would be the same. The separate key is used for each round. However, same round keys are used for encryption as well as decryption. So this is all about your data encryption standard, which is a symmetric cipher, symmetric encryption technique. Symmetric encryption technique means in the encryption side the key has been used, the same key has been used in decryption sides. If you have any doubts, do let me know. You have my details, and we'll discuss another topic in the next class. Thank you. Have a good day.